welcome everyone. My name is Andy, I'm from AlphaESS. I'm the technical manager for Alpha in the UK. And today we're just going to go through the new Smile-G3 range of inverters and how we go through commissioning those, and the new offering from Alpha, the 7 kilowatt EV charger. So with the inverter, the first thing we've got two versions. There's a 3.68 version and a 5 kilowatt version. There will be an 8 kilowatt version coming Q1 next year. There's a lot more demand for those larger single phase systems, and we do have a 3-phase offering. Please come and visit us on the Alpha stand should you want to get some more information on that. We've got some brochures here as well you can take away. So with the 3.68 inverter, we can put, they're hybrid inverters, we can put 200% PV on there. So on a 3.68 inverter we can put 7.36 kilowatts of PV, and on the 5 kilowatt inverter we can put 10 kilowatts of PV. And what we can do, we can use all of that energy. So we can charge the battery. If we've got a 5 kilowatt inverter with 10 kilowatts of PV, we can charge the battery at 5 kilowatts, and we can output 5 kilowatts as well. So the only time we start clipping is when the battery is full. So it's a real versatile solution. We have a backup function, so we can back up critical loads up to the size of the inverter. So we can kind of take a sub board off that backup and power those loads. They're continuously powered, and when the grid is lost, that backup port is continually powered. We've done some real big work on the installation, the speed of installation for these systems. We've seen that as a real sticking point for the installers, where they want the process to be as seamless as possible. So now we've just got a bracket. This battery here is a 4 kilowatt hour battery, and it has a wall bracket. So there's one wall bracket per battery. They all mount together, and then the inverter just sits on top of the batteries and just screws in. So there's no additional brackets. There's no measuring out different parts to fit in different places to maintain gaps or anything like that. So again, really kind of quick install. With the 4 kilowatt hour battery, we can have up to 4 of those 4 kilowatt hour batteries, giving us maximum 16 kilowatt hours with that particular battery. It's lithium iron phosphate, same as everyone here pretty much, and it uses a high voltage battery scheme. So the batteries themselves are of 96 volts, and it's a series battery. So if we have 4, we have 4 times 96 at the inverter. So in terms of conversion, that conversion process is really efficient. We do have another battery module we can use this with the system. We can use a 10 kilowatt hour battery, a 10.1, and that's a parallel battery, so we can have multiple of those batteries. And again, that's a 96 volt battery operating on that higher voltage of battery cell. So once we've installed the unit on the wall, we need to connect up our AC supply. There's a plug for the AC supply, so you can wire that up away from the unit and plug it in, so you're not fiddling about underneath. There's another plug for the backup port. Hybrid inverter has 2 MPPTs on there. We need to make sure our voltage range for those MPPTs is between 100 and 550 volts. We can take up to 15 amps on the MPPT. And we've got our battery connection, so we need to connect to that first battery with our positive cables, and we need our BMS cable, a data cable for the BMS to go into the EMS board. And once we're set up, the commissioning process is really streamlined. I made a video last week where it takes about 5 minutes to complete the commissioning process. We just need to put in how much PV we've got installed, whether we're using a meter or a CT clamp, and the safety code for the system. So I've got one of our meters here. There's a DTSU meter. What we're recommending is you use the meter if your grid incomer is more than 10 meters away from the system. Because we have some plug-in CT clamps that the leads are 12 meters. So if we're going to go over that, we used to say you could extend the cables, but we found a lot of customers where there were poor joins or poor cables used, so the reading back at the inverter was really bad. So we're saying if you're going over that 10 meters, we recommend you use the meter. There's a data cable connection on the top, so you can use a standard RJ45 cable from the meter and an RJ45 cable at the inverter and just plug it straight in. And it's better to extend that cable than to extend the CT clamps to get a really poor reading on the AlphaESS ecosystem. So our systems need to be connected to the internet. So we do have a Wi-Fi dongle for these systems. It comes in the box, it's not an optional extra. And there's just a process you need to go through to connect your phone with the AlphaESS app to the Wi-Fi network of the system. There's a the serial number will be broadcast as a network, and then you can connect the phone to it, and then tell the AlphaESS app what Wi-Fi network you want to connect the Alpha system to. And that's the process is pretty straightforward. There is a LAN port on the system, so you can plug a LAN cable directly from the inverter to the customer's Wi-Fi broadband router. That's our preferred method of connection, purely because if the customer changes their broadband provider, they change their router, they've not got to go through those reconfiguration steps. They can just unplug the cable from the old one, plug in the new one, and they get that seamless connectivity. So what we've got next then, we've got the AlphaESS EV charger. So this has been launched at the show today. Via our main distribution channels, Waxman Energy, City Plumbing, and Rapid Renewables. They're doing a deal at the moment. Buy 2 batteries, get the EV charger for free. So the EV charger's been introduced, so we've got people were buying EV chargers from different brands. Customers were having multiple apps for controlling this, controlling that. So we wanted to bring one out that would integrate all together with the AlphaESS app. So it's a really straightforward install. I'll go through the specs on the screen. So it's a 7 kilowatt EV charger. It's a single phase 7 kilowatts. It's integrated into it's fully integrated into the AlphaESS app when used with the G3 range. There are a couple of RFID cards in the box, so you can. I'll go through the operation mode shortly. If you live in a busy area, you can use the cards to start and stop the charger. You can also start and stop in the app, but I'll go through that shortly. Standard Type 2 socket. It's not a tethered unit, but we are selling it with the cable included. It's got an integrated 10-volt detection, so there's no additional boxes or anything you need to install. It's a really simple installation, as I'll go through in the next steps. And the smart features with this system are only available when used with the G3 inverter. Okay, so in terms of installation, the box is sealed. You don't have to take anything apart to install it. There's just a small bracket that will go on the wall, and on the bottom here we've got our mains connection, and we've got our data cable connection. So we mount our bracket on the wall, locate the holes, and there are just 2 screws on the sides to lock that into place. And there's just a picture here. There's a data cable required from the G3 to the EV charger. That's the only other connection we need. And the system will use the internet connection and the EMS and the CT clamps from the Alpha inverter to operate the car charger with its smart functions. So just on the bottom there, there's a connector, waterproof connector where you can put your grid connector into, tighten it up and plug it in. And again, there's a waterproof connector for your RJ45 cable to make sure that no water can get into the unit. And just on the EMS port, on the inverter, you can take a look in a second. There's a bank of RJ45 connectors, and there's one labelled CAN/RS405, and that's when that data cable plugs into. So in terms of commissioning the EV charger, once you've connected up, you've got your inverter commissioned, you need to go into your AlphaESS installer app, click on the Me icon, and you can go onto the Install EV Charger section. And to install that EV charger, we need the serial number of the inverter, we need the check code on the side of the inverter, they'll both be on the label on the side there, and we need the EV charger serial number, which is just on the side of the EV charger here. It will automatically sense which charger we're using. You just need to select the installation date and then click the submit button, and then the charger will automatically be added to the customer's AlphaESS app. And what they'll find, there'll be a new field at the bottom here to say for the settings for the EV charger, and there'll also be another field to say the power that the EV charger is using at that particular moment. So on this picture, the car's not plugged in, it's not charging, so nothing's going on. And to get to the settings, we can click on the My EV Charger, and it will show the page with what the system's doing. We've got those start and stop buttons should you want to start and stop it, depending on what work mode we're in. And we've got the settings cog at the top right hand corner. If we click on that cog, it'll take us into the charging settings for the charger. Top of the page, really important thing to add in there when you're commissioning the system is the maximum current property. So generally in the UK, 100 amps, 80 amps. If that's set incorrectly and you're trying to use multiple things at the same time, trying to charge the battery and charge the car, and this is set to 30 amps, the system the car will stop charging because it's using too much energy than we think is allowed in the property. So it's important that's set correctly. And then below that we've got our charging strategies. So there are 3 different charging strategies for the EV charger. We've got a manual setting, a time charging setting, and a plug and play setting. So we'll just look a bit deeper into those. So the manual strategy is that when the car will start to charge only when either the RFID card swipes or you press the start button in the app. So if you live in a busy area, you might don't want people just plugging in and starting to use your charger. You can set it so it's a bit more secure, and so no one can steal your energy from your charger. The next one we've got is the time charging. So if you're on one of the smart tariffs with off-peak charging, you can set the time in the app to allow the car charger to only charge during that time. And then the last one we've got is just the plug and play strategy, where if you just plug the car in, it will start to charge dependent on the charging mode we're in. So then we've got our different charging modes. We've got 3 different green charging modes and a fixed power charging mode. So the fixed power charging mode, we can set the amps of the power of the charger, or we can use the three green charging modes. The first one being slow charge. So this is when the battery is full and we've got some excess PV. If we want to charge the car from that excess PV, as long as there's more than 6 amps going to the grid, the car charger will come to life and start to charge the vehicle and soak up that excess PV. So great for not using the grid and driving for free effectively. So that's the first mode we've got. The second one we've got is a green mode general charge. So similar to before, we would be using the sources we're using to charge the car is the sun and the battery. So however much PV we've got generating, we will use all of that energy, then we will use the battery to charge the car as well. So we dump in our battery into the car. And the priorities, first one being the property, and the second being the car. And the final charging mode we've got is the fast charge, which again uses the sun and the battery to charge the vehicle, but the priority is the vehicle and then the property. Then we've just got the last one is the specific charging mode, where you can set the number of amps that are going to go to the car charger. So what can happen if you're using the green slow charge and you need to maintain 6 amps going to the vehicle? It might be that 6 amps is up and down and the car's dropping in and out. So what you can just use a lower charging mode. You might use some of the battery, but you'll maintain that charging regardless of the sun coming in and out. Well, that's all the slides I've got on the car charger and the AlphaESS amp. We've got some brochures at the front here, should you want to take any. We've got a giveaway for the car charger right now as well. There's a QR code there you can scan to enter into that competition to win the car charger. But again, if you want any further information on AlphaESS, drop us a line or come over to the stand over in D147 over the other side. Does anyone have any questions?